This is question number 1 in the non-calculator. We're asked to find the equation of the straight line shown in the diagram above. Now, when finding the equation of the straight line, we have a choice of two to work with. Y minus b equals m bracket x minus a, or y equals mx plus c. Given the fact that we have a diagram, the grid is clearly visible in the background, and we can also see where the graph crosses the y-axis. That tells us that the one that we should be using is y equals mx plus c. So m is the gradient of the straight line and c is the y-intercept. We can clearly see the y-intercept, that's the line, or the point I should say, where the line crosses the y-axis, so that's our c value. What we also need, as we mentioned, is m, the gradient. And since we have our grid, we can achieve that by picking 2 points on the line and making a triangle. So we'll choose this one here and this one here, which allows us to draw a right angled triangle. With the right angled triangle, we can clearly see the vertical height of the triangle and the horizontal distance. So that means we can use our gradient formula, m equals v over h, the vertical height of the triangle divided by the horizontal distance. So the vertical height is 3 boxes, and the horizontal distance is 1, 2, 3, 4 boxes. That then gives us a gradient of 3/4. So we can now substitute that into the straight line equation down at the bottom, y equals mx plus c, along with our y-intercept, which is still marked on our diagram. So that then gives us y equals m, the gradient, which was 3/4 x, plus the y-intercept, which is 3. That's now the equation of a straight line and the end of the question. Question number 2 in the non-calculator asks us to multiply the brackets and collect the like terms. So we have a set of double brackets to be multiplied out, and then we have the plus 8x at the end. So the first thing I'll do is make this a little bit bigger, move it over. So multiplying the double brackets first of all, we have the 3x from the first bracket to multiply the second bracket, x minus 5, and then the plus 2 from the first bracket to multiply again the second bracket, x minus 5, and then we have that plus 8x at the end. So multiplying the first bracket by 3x, 3x times x is 3x squared. Take away, and then we have 3x times 5, which is 15x. Moving on to the second bracket, we have 2 times x, which is 2x, and then 2 times negative 5, which is negative 10. And again, we have this plus 8x on at the end. The next thing we want to do is we want to collect our like terms. So we can see that there's a negative 15x here. Then we have a plus 2x, and later on we have a plus 8x. The 3x squared is on its own, and the negative 10 is another one on its own. So we'll put our 3x squared down first of all. We have negative 15x, add 2x first of all, which gives us negative 13x, and negative 13x add 8x is then negative 5x. Finally, we have the negative 10 on at the end. So we don't have any more like terms, which means it's fully simplified, and that's our final answer. Question number 3 in the non-calculator. We're asked to express root 40 plus 4 root 10 plus root 90 as a surd in its simplest form. So looking at root 40, first of all, it can be simplified as 4 times 10. Then we have plus 4 root 10, which can't be simplified. And then we have root 90, which can be simplified as 9 times 10. So root 4 times 10 can be split into separate roots, root 4 and root 10. Then we have our plus 4 root 10 in the middle. And then at the end, two separate surds, root 9 times root 10. So the square root of 4 is 2 root 10. And then we have 4 root 10. And the square root of 9 is 3, then root 10. So we're now in a situation where we have all root 10s. So we can simply just add them together. We have 2 root 10, add 4 root 10, which will be 6 root 10. Add another 3 root 10, and that gives us 9 root 10 altogether. That's it, fully simplified. So that's the final answer. This is question number 4 in the non-calculator. The diagram below shows part of the graph of y equals ax squared. We're asked to find the value of a. So that's the equation of our curve. It's a parabola, which means it's a quadratic equation. We want to find the value of a, and we're given this point negative 3, 45, which lies on the line. So what we're going to do is we're going to take the x and y value from our point, substitute it into our equation, which will allow us then to find the value of a. So move this over a bit to give us some more space. So I'll write down the equation of our curve, y equals ax squared. Our x value is negative 3 and our y value is 45. So substituting those in, we get 45 equals a times x squared, which is negative 3 squared. So that's 45 equals a times negative 3 squared is negative 3 times negative 3. So that's positive, and it's 9. So we've got 45 equals a times 9, which is 9a. Flipping that round, we have 9a equals 45. Now the last step is to take the 9 to the other side. So 9 is currently multiplying the a, which means when we take it onto the other side, it will divide the 45. So we have a equals 45 divided by 9, which is 5. a equals 5 is the final answer. This is question number 5 in the non-calculator. Part of the graph of y equals a sine bx is shown in the diagram. State the values of a and b. So in order to do this one, we must remember the graph of y equals sine x. So I'll put this down on screen. So if we compare our graph with the graph of y equals sine x, we can see that this part here is this part here on the graph of y equals sine x. Now what's missing from this graph is the part that would come down and trace back up to complete the first cycle, which we can then see on this graph here. So we can see that the y equals sine x graph passes through here at 180 degrees, and that part on our graph passes through at the same point. So what that means for our graph is if we were to complete this first cycle, then the graph would finish up at the same point, 360 degrees. So what that means is that our graph has the same period as the graph y equals sine x. Our graph is written with two unknowns, y equals a sine bx. Since the period of the graph is the same as the one for y equals sine x, then this means our unknown b value is also the same, which is in fact 1. So we have y equals and sine 1x, which is just written sine x. I've left space in here for our value of the other unknown a. So if we take a close look at the graphs, we'll see that the maximum value of y equals sine x is 1, and the minimum value of sine x is negative 1. Our graph, however, has a maximum value of 3 and a a minimum value of -3. This suggests then that our original y equals sine x graph has been multiplied by 3, so that makes our other unknown value a equal to 3. So our graph is y equals 3 sine x. That's the equation of the graph here. The question actually says state the values of a and b, so we better write those down explicitly. So a is equal to 3 and b was equal to 1. That's the final answer and the end of the question. This is question number 6 in the non-calculator. A parabola has equation y equals x minus 2 all squared, take away 5. Part A asks us to write down the coordinates of the turning point of the parabola. And then part B, does the parabola have a maximum or minimum turning point? So if the parabola is a maximum shape, that means the graph will look like this. And if it's a minimum, it will look like this. So the maximum turning point would be up here and the minimum turning point would be down here. So looking at the equation up at the top, we can tell the difference between the two parabola shapes by the x squared term. If the x squared term on squaring out the brackets were positive, then we get this shape here, a minimum turning point. If when squaring out the brackets the x squared term was negative, then we would get this shape here, which is a maximum turning point. It should be fairly obvious, even without setting down any working, that if you square out the bracket you will get a positive x squared term, which means our answer is in fact going to be this type. It's going to be a minimum turning point. In this form here, it's actually a fairly easy procedure in order to find the turning point. So the turning point, which we know is going to be a minimum, will be made up of an x value and a y value. The minimum value of our quadratic equation or parabola occurs when the square part becomes equal to 0. So in order to find that, we need to make the bracket itself become 0, which means we must choose the appropriate x value. In this case, x would need to be 2 to make the bracket 0. So 2 is the x value of our minimum turning point. That then leaves us with y equals -5, the minimum value of the quadratic. So 2, -5 is the minimum turning point. We need to state it as a minimum. And once we do that, that will then be the end of the question. This is question number 7 in the non-calculator. The diagram below shows a circle centre C. The radius of the circle is 15 centimetres, so that would be the measurement from C out to B, the radius. A is the midpoint of the chord PQ, so that's this one here, and the length of AB from here along to here is 27 centimetres. The question asks us to calculate the length of PQ, which is the chord. So we stated a moment ago that the radius of the circle is 15 centimetres, and we pointed the radius out here. But we need to remember that the radius can be drawn in anywhere. So if we draw the radius from here to point P, then that provides us with a right angled triangle. Now the question is to find the length of PQ. If we think about this part first of all, which is one of the sides of the right angled triangle, if we were able to work out that red side, then it would just be a case of doubling it in order to find the length of PQ. We know that the radius is 15 centimetres. We know that the distance from A to B is 27 centimetres. So since this part here is 15, then it must mean that this part here is in fact 12 centimetres. So we now have a right angled triangle where we know two sides, and we're looking to find the length of a third side, which we'll call x. It happens to be one of the shorter sides. So to give us a bit more space for our working, I'll move this over here, making it a little bit smaller. So the shorter side squared will be equal to the long side squared. Take away the other short side squared, according to Pythagoras. So x squared is equal to 15 squared, which is 225. Take away 12 squared, which is 144. That means that x squared is equal to 81. Taking the squared over to the other side makes it square root. So that's square root of 81, which means that x is equal to 9 centimetres. Now that is just half of the chord PQ. We were told that A was the midpoint. So in order to find the length of PQ, we are going to double x. So PQ is going to be equal to 2 times 9, which is then 18 centimetres. That's the length of the chord PQ and our final answer. This is question number 1 in the calculator section. We're told that there are 964 pupils on the roll of a high school. It is forecast that the roll will decrease by 15% per year. What will be the expected roll after 3 years? And then it says give your answer to the nearest 10. So if we think of our original percentage roll as 100%, a decrease of 15% means 85% left over. 85% as a decimal is 0.85. So we set it down as follows: 964 multiplied by 0.85. The reduction is over a 3-year period, 15% each year. So that means our power here is 3. We then use our calculator to work this out, giving us an answer of 592.0165. Our answer has to be given to the nearest 10, so that's 590 pupils. This is the estimate for the roll after 3 years and our final answer. This is question number 2 in the calculator. Part A, a candle is in the shape of a cylinder with diameter 10 cm and height 15 cm. Calculate the volume of the candle and give your answer correct to 3 significant figures. So we use the formula for the volume of a cylinder, which is V equals pi r squared h. We are told that the diameter is 10 centimetres, so we need the radius. If the diameter is 10 centimetres, then that means the radius is half of that, which is 5 centimetres. We are told that the height is 15 centimetres. That then gives us enough information to use our formula. So we'll substitute those values in. We have V equals, and then it's pi, multiplied by the radius squared, which is 5 squared, multiplied by the height, which is 15. So if we then use our calculator, we can work out the value of our volume, which is 1178.09 with several more decimal places. The question asks us to give our answer to 3 significant figures. So if we round our volume to 3 significant figures, we get 1, 1, and then because the number beside the 7 is a number 8, it means the 7 rounds up to become 8, and then we need a 0 in as a placeholder. That then gives us our volume as 1180, and it's cubic centimetres. That gives us our answer for part A. We can now take that on to part B. So part B tells us that a second candle is in the shape of a cone with a circular base of diameter 14 centimetres and height h centimetres. It has the same volume as the first candle. Calculate h. So this time we're going to use our cone formula. We know that the volume of a cone is V equals 1/3 pi r squared h. We would normally use this formula to work out the volume, but in this case, since we know the volume is in fact the same as the volume of the original candle, 1180, then that means we can use this formula to work out the height of our cone instead. So we want to substitute these values into the new formula. So the volume, which is the same as the other one, is 1180 equals 1/3 times pi times the radius squared. We know that the diameter of the cone base is 14 centimetres, which means that the radius would be 7. So that's 7 squared, multiplied by h, the unknown height. So tidying up what we have at the moment, we have 1180 on the left hand side. We then have 1/3 times pi times 7 squared, which will be 49, multiplied by the height. So we can write that as 49 pi h, and the 1/3 means that we're dividing this all by 3. So we then flip this around so that we get h on the left hand side. We get 49 pi h over 3 equals 1180. Taking the 3 onto the other side gives us 49 pi h equals 1180 times 3. So again, just give ourselves a bit more space here. 1180 times 3 is 3540. We have 49 pi h on the left hand side. We want h on its own. So the 49 pi, which was multiplying the h, can be moved onto the right hand side, which means it will divide the number 3540. We can then put this straight into a calculator to work out the height, which turns out to be 23 centimetres if we round it to the closest centimetre. So that's the height of our cone and the end of the question. Question number 3, we're asked to factorise fully. So we have a trinomial here. What we should spot first of all is that we can take out a common factor of 3. So we'll do that first. We have 3 outside the bracket, leaving us with x squared plus 3x minus 4 inside. What we then need to look at is the part inside, which we're going to factorise into double brackets. So we have our 3 and then our double brackets. We'll set the working out for this at the side, so we'll give us a bit more space here. So the working at the side, we'll put one bracket above the other. We're looking for two things that multiply to give us x squared, which is obviously x times x. Then we move to the other end where the number is 4. So two numbers that multiply to give us 4, but at the same time they need to somehow combine by adding or subtracting to give us plus 3. So two numbers that multiply to give you 4, you might first of all think of 2 times 2, but that won't work, so we're going to try 1 and 4 instead. So putting in our cross, x times 4 is 4x, and x times 1 is x. That then needs to be equal to the thing in the middle, which is plus 3x. So the sign is obviously important here. To get plus 3x from these two, we have to make the 4 positive and the x negative. Positive 4x take away x gives us positive 3x. So that means that x times 4, the 4 has to be positive, so it's plus 4x. So that means positive 4. And then the x times the 1 has to give us negative x, so that means the 1 has to be negative. That gives us our two brackets, x minus 1 and x plus 4. We now have our fully factorised form, which is our final answer. Question number 4. Mr. Smith and Mrs. Curran both shop at the same store. Part A. Mr. Smith bought 3 loaves and 2 packets of butter. The total cost was £4.73. Let x be the cost of a loaf and y pounds be the cost of a packet of butter. Write down an equation in x and y which satisfies the above condition. So 3 loaves will be 3x. We're adding 2 packets of butter to that, so that's 2y. And the total cost, we'll drop the pound sign for the minute, is £4.73. Part B. Mrs. Curran bought 5 loaves and 3 packets of butter. The total cost was £7.52. Write down a second equation in x and y which satisfies this condition. So once again, 5x for loaves plus 3 packets of butter, so that's 3y, and that will be equal to £7.52. And once again, we'll drop the pound sign. So that's the first two parts, A and B. Part C, use equations in parts A and B to find the cost of a loaf and the cost of a packet of butter. So this is obviously a simultaneous equations question. We have our 2 simultaneous equations to work with. So we'll write these down together and look to cancel out either the x's or the y's. So giving us a bit more space here. We have our first equation, 3x plus 2y equals £4.73, and 5x plus 3y equals £7.52. We'll call this one equation number 1 and this one equation number 2. So in order to solve these simultaneously, we want to first of all eliminate either the x's or the y's. We do that by picking which one we want to eliminate. So in this case, we'll choose the y's. What we then do is we multiply either one or both of the equations in order to make the y's the same value. We want one of them to be negative and the other one to be positive, so that we can then add equations 1 and 2 together, which then causes the y's to disappear. So what we're going to do in this one is multiply equation 2 by 2 to make it 6y, and multiply equation number 1 by negative 3 to make it negative 6y. So whatever we do to the y's, we must do to the other terms. Looking at equation number 1, first of all, we have negative 3 times 3x, which is negative 9x. Then the negative 3 times the 2y, which is negative 6y. And then we have negative 3 times £4.73, which is negative 14 pounds 19. Moving on to the second equation, multiplying by 2. 2 times 5x is 10x. Then 2 times 3y is 6y, positive 6y. And then 2 times £7.52 is £15 and 4 pence. So what we want to do now is add them together. When we add, the negative 6y and 6y will cancel out and be eliminated. So negative 9x add 10x is x, and negative 6y add 6y, those two cancel out. Then we have negative £14.19 add £15.4, which is £0.85 or 85 pence. So what we want to do now is we want to substitute x equals 0.85 into equation 1. So that's 3 times 0.85 plus 2y equals £4.73. 3 times 0.85 is £2.55 plus 2y equals £4.73. Moving the £2.55 onto the right hand side gives us 2y equals £4.73. Take away £2.55, which then gives us 2y equal to £2.18, which means y equals £2.18 divided by 2, which means that y equals £1.09. X was the cost of a loaf of bread, so that means a loaf is 85 pence, and a packet of butter was represented by y, so that means the butter is £1.09. That's the end of the question and our final answers. This is number 5 in the non-calculator. We're asked to solve the equation 2x squared minus 7x plus 1 equals 0, giving the answers correct to 2 decimal places. So since this is in the calculator section, and also because it says giving the answers to 2 decimal places, then that suggests that this quadratic equation is going to be solved using the quadratic formula. So our quadratic is of the form ax squared plus bx plus c equals 0. That means that our a value is equal to 2, b is equal to -7, and c is equal to 1. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So we can take our values of a, b and c and substitute them into the formula. So that then gives us x equals -b, which is -7, plus or minus the square root of -7 squared minus 4 times a, which is 2, times c, which is 1. That's all over 2a, which is 2 times 2. So move this up a little bit to give us some space. So we have -7 at the start, which is just 7. Then it's plus or minus the square root of -7 squared, which is 49. Then we have -4 times 2 times 1, which is -8. And that's all over 2 times 2, which is 4. That then gives us 7 plus or minus the square root of 49 minus 8, which is 41, over 4. We'll move that up again to give us some more space. Now, quadratic equations in general produce 2 solutions. So that's where the plus and the minus sign comes in. That allows our formula to split into 2 separate branches. So we have our x equals 7 plus the square root of 41 over 4, or, and our second solution, x equals 7 take away the square root of 41 over 4. So using a calculator, we can now work these out. So the first of these is x equals 3.35, rounded to 2 decimal places as requested in the question. Or, and for our second answer, x equals 0.15, once again rounded to 2 decimal places as requested. Those are our 2 solutions and the answer to the question. Question number 6. We're given a formula, P equals QR squared over 3. The subject of the formula is P. The question asks us to change the subject of the formula to R. The first thing I'm going to do is move this over a bit to give us some more space. So we currently have P equals QR squared over 3. I'm going to flip this round to give us QR squared over 3 equals P. The purpose of that is to get the R onto the left hand side. If R is to be the subject, then it will need to be on the left hand side. We want to now start moving the other things that are beside the R away and on to the other side of the equal sign. So the first and easiest thing to move is the 3. If I take that onto the other side, it's dividing where it is at the moment, which means it will multiply the P when it moves to the other side. So the next line will be QR squared equals P times 3. So that's QR squared equals 3P. Next thing we're going to try and move is our Q. It's currently multiplying the R squared, so when we take it to the other side, it will divide. So that then gives us R squared equals 3P divided by Q. So we have one more thing that we need to move onto the other side, and that's the squared. So when we take squared over onto the other side, it once again does the opposite, it will square root. So that then gives us R equals the square root of 3P over Q. R is now the subject of the formula, and that means our question is over. Question number 7. We are given an algebraic fraction involving indices and we're asked to simplify. We're going to start with the denominator, 2p cubed multiplied by p. So we should know that the p here has a power of 1, even though it's not shown. When we multiply, the rule is that we add the indices. So the next line of working will be 8p to the power of 6 over 2p, and then adding those indices together gives us 4. So we now have a division to do. We have 8 divided by 2, which is 4, and then it's going to be p to the power of something. Now once again we have a rule for division, and that is that the power on the bottom will be subtracted from the power on the top. So 6 take away 4 is 2, which leaves us with 4p squared. That's it fully simplified, so that's the end of question 7. Question number 8. We're given 2 individual algebraic fractions which we are to add. We're asked to express these as a single fraction in its simplest form. Now, without going into too much detail, if the denominator of a fraction is to become 0, then the value of that fraction is then undefined. So on our first fraction, if we were to make x equals 4, we would have an undefined fraction. And on the second one, if x were equal to 0, it would be undefined. So this bit over here at the side is enough to put some folk off when they're trying to do this. It's mathematically correct, but it has no bearing on how we attempt the question. So we are simply going to ignore it from here on in. So in order to do this addition, we use the kiss and smile method. So that means we're going to multiply the 2 by the x, and then the bracket by the 5, and then finally the two denominators together. So our next line would be 2 times x, which is 2x, plus, and then our bracket times 5, so we'll put the 5 at the front of the bracket. And on our denominator, we will have our bracket times x, so we'll put our single x at the front. Now, in order to simplify the numerator, we're going to multiply out the fraction, the bracket I should say. which means then we will be able to combine the like terms. We don't want to multiply the bracket out in the denominator, however, because there is always a chance we could simplify by cancelling. That won't be possible if we multiply it out. So we'll leave the denominator as it is. So on the numerator we have 2x plus, and then 5 times x is 5x, take away 5 times 4, which is 20, over x bracket x, take away 4. So combining the like terms on the numerator, that then gives us 2x plus 5x, which is 7x, take away 20, over x bracket x minus 4. There are no more like terms. No further factorising or simplifying is possible. That therefore means that this is our final answer. Question number 9, and the last one in the calculator section. The barrier at a level crossing is raised after a train has passed. The height h, which is in centimetres, of the end of the barrier can be calculated using the formula h equals 320 sin x plus 150. We are then told that x exists in the interval 0 to 90 degrees, so therefore x is an acute angle. We are asked to calculate the size of the angle x when the end of the barrier is at a height of 458 centimetres. So we will achieve that by using our formula. So we'll write that down to begin with. H equals 320 sin x plus 150. So we know that the height is 458 centimetres, so we can sub that in for h. So that's 458 equals 320 sin x plus 150. We are hoping to find x, the angle, so we're going to rearrange our equation and try and make x the subject. So we'll move this up a little bit to give us some more space. The first thing we're going to do is flip the equation round to get the x on the left hand side. So that gives us 320 sin x plus 150 is equal to 458. So then moving our plus 150 across the equal sign, which means it will subtract. That gives us 320 sin x equals 458. Take away 150. That means then that 320 sin x is equal to 308. We're going to move the 320 across the equal sign now, so it will change from multiply to divide. So that then means that sin x is equal to 308 divided by 320. So working that out on our calculator gives us sin x is equal to 0.9625. Now at this point we use our CAS diagram. So put this down, all sine, tan, cos. The fact that this value here is positive tells us which quadrants we're going to use, and tick. So that's going to be the all quadrant and the sine quadrant. Now if we go ahead and find the inverse sine of our value using our calculator, then the answer produced will be the answer from the all quadrant. If we want to then find the answer from the sine quadrant, we would then subtract this value from 180 degrees. But if we cast our mind back to the start of the question, we will remember that our answer has to be in fact an acute angle, which means in this case we can ignore the sine quadrant answer completely. The answer we need is the answer from the all quadrant. So that will be the one that we get straight off from the calculator. So we'll go ahead and work that out. The answer for x, our angle, is going to be the inverse sine of 0.9625. So once again, going ahead and doing that on our calculator gives us the answer for the acute angle between the barrier and the horizontal, which is 74.3 degrees corrected to 1 decimal place. That's the answer and the end of the question.